learning from the Mark 1 laser pointer and from a viewer who made one himself, I've decided to make a Mark 2. Now I followed his example and made it out of aluminium, but I've changed the design in several different ways. We'll talk about that when I take it out the lathe, but at this very moment in time is something like about 1.5 meters away. So what I'm trying to do now is to get the laser beam coaxial with the axis of the jig itself, or the rotational axis of the machined parts of this jig. We'll turn it through 180 degrees and see how well that is for centerline. No, that's not very good. We need to bring that one up onto center. We turn it 180 degrees. Well, I would say that probably at 2 meters away, and we only got to be 1 meter away for our longest track on the machine, that's probably not bad. Just hold that there. We're about 6 inches away from the chuck. And as you would expect, unless there's some serious problem this close, it would still stay perfectly in line. So I'm very happy that we've got that now collimated. Well, I'm now going to show you the finished item. It's got loads of screws all over it. We've been able to steer this piece coaxially with these screws. We're now going to fix it onto this face here on the end of the water jacket. I'm hoping that without using these additional screws here which I've put in, which as you can see they stick through the back here, and they will allow me to steer the beam. So if the beam doesn't come out of here absolutely spot on, then we've got a chance of correcting it and making it come spot on. So the plan with this version, whereas previously I plugged it into the end there, what I'm going to do is to reference it off this outside edge to get the best register I can, and to do that I've got to somehow fix it on there like that. Now what I'm going to do before I start, now this might not be the clearest picture because we're actually looking through the glass in the top of the in the lid, but what I'm going to do is just put a pulse now. I hope you can see I'm using about 20% power. I've just got the merest hint of a burn mark in the middle there. I'm first of all going to turn my laser beam off. There we go. So the laser beam is now disabled, so it's safe to work in this area. Right, we're now going to connect this onto the end here, like this on its register. Oops. So we've got a registration on there now, and I'm going to put an elastic band around that pin and put the elastic band around the back of the water pipe. I'm going to hook the elastic band back over the pin like that. Now I've got to do the same to the bottom pin as well. Put that round the pin, around the back of the water pipe, and back over the pin. There we go. So that is now pulled back like a spring onto there. There we go. And we'll see when we turn the pointer on. Let's connect the pointer into the power. So I hope you can see there that the beam is quite a long way low. And there we are. Eventually we've managed to get the red dot spot on to the burn mark. Okay, so now when we move the mirrors or the laser, we should be reproducing what will be coming out of the laser when we turn it back on. Right, well here we are at the front of the machine, so let's just turn the laser pointer off for a minute. It takes a few seconds to disappear, and then we'll turn it back on. just a fraction low, so that we can see the scorch mark, and then we'll turn the beam on. Yeah, I would say that's just about spot on. So we can traverse that to the back of the machine and see whether the spot moves. No, but it does move very slightly. It's in exactly the right spot there. It seems to drop in the middle there. And then come back up at the front. Now you wouldn't normally notice that if you were doing a pulse burn, because you wouldn't bother to check it all the way along the stroke. So if we take a look at the back of the back corner of the machine there, you can clearly see that the spot is in exactly the same position. If we move to a halfway point along the axis, you can see that the beam has dropped 2 millimeters. That's interesting, because by the time we get to the front, it's back on target again. So as you can see, it's going to be difficult to see what's on this particular target here. So what I've done, I've put a little mirror on here so that we can see a reflection of what's on this target. 1, 2, 3 lines out, 8:30. I think we're still 3 lines out at about 8:30. So that beam is running true to the axis in both planes. Right, now we've got this one spot on as well, we will check what the vertical situation is. I mean, I can already see, I hope you can see that as well, but just about in the centre there, but not quite on centre, is the beam, the little red beam. So it's looking pretty hopeful. The red spot is very clearly there to me at around about, well, it's in line with that big line there at around about 8 o'clock. And when I look in there, you can just about see that again it's around about on the end of the line at 8 o'clock. So I would say that that beam is going down more or less vertically to the surface of the table. So as far as I can see, everything is set up well. I suppose the ultimate test will be to leave that there. Right, we've removed the pointer from the machine. I've turned the laser on and we'll give it a quick pulse. And wowee, look at that. It's spot on where the pointer was. I think the Mk2 pointer, with a few very small minor improvements, is the ticket. Now I'm just going to clean this mirrors because particularly the one at the end there, in case I've done anything like smoked it. No, that's pretty clean. They're all pretty clean, the mirrors. I will just check the lens. Now, as I may well have mentioned to you before, but it's worth mentioning again, when I first got my machine, the lens was put in the wrong way round. This is the correct way to have the lens, with the flat side down to the work. This lens has got a slight film on it, so we'll just remove the film. The great advantage of isopropyl alcohol is you can watch it dry. You actually just put a little bit of air on it and it will even dry it even quicker. There we are, we've got a nice shiny surface on there now. We will run the spiral test in a minute, but before we run it, I just want to check that when it runs at 20 milliamps. Well, it will do when it starts the test. No, it's gone to 15 milliamps. There we go, a little bit of a nudge and it's gone to 20 milliamps. Run the same thing again. And I would think it'll probably jump straight up to 20 milliamps now it's had a kick. But I think it's dropped into 20 milliamp mode now. There we go. Now what that is, I've got no idea. I would have thought it might be a loose connection somewhere, which when I kick it like that or give it a gentle tap, it makes a connection, but I don't know. Yeah, so we've just about got 30 watts there. So we've just checked and we've got 30 watts coming out of the nozzle. So we're trying to cut 10mm acrylic here with 30 watts. We're running at 2mm a second. We can see we're cutting through because the smoke is coming out underneath, not on top. There we go. Saw it starting to fall out. So that's what you can do with 30 watts.